1997 Ford F-250 heavy duty with the 7.3 power stroke. Customer complaint is, and we confirmed you're driving it around. Sometimes it'll drive nice, sometimes it just shudders. Not a, diesels don't have necessarily misfire, but a cylinder contribution, and that's what it acts like. So, if we did a full system scan, there was no codes in there, which you can't do much on these older Fords anyways. But however, we think it's an injector issue, and we're going to do some tests on this. But I'm going to do a key on engine off injector read test. And what we'll hear is all the injectors clatter at once, and then we're going to hear them 1, 2, 3, 4, 5, 6, 7, 8, just to make sure everything's kosher with that. So I'll do that right now. Sorry about the glare, as normal. Now listen up. I gotta switch the key here, and I gotta redo some stuff. So I just did this test. Okay. I have to go back on the comm. Again, key on engine off. Hit OK. All right, so you could hear them all click, and then there was 8 injectors, all sounding pretty even, which is good. So now what we're going to do next is we're going to test drive it. All right, so what we're going to do now is we're taking for a test drive. What I got here is engine oil temperature, 167 degrees, fill pulse width. Hopefully you guys can see this. I'm trying to film, but my phone's about to die, and I can't really see much with it. Injector pressure regulator. On the 6-sols, I know this is 7.3, but the 6-sols, if it was at 84, 85%, that'd be actually a true 100%, where it would command full open oil pressure going to it. I like the 6-sol. You got a low pressure pump on these, and then for a fuel pump, and then it goes to the high pressure oil pump, and the injector pressure regulator controls that high pressure to go to the injectors to atomize the fuel. So we want to watch that, make sure it's not going above, it should stay 30, 35, 40%. If it's going full command, and we've got a leak in the high pressure oil system. Also, I have the injector control pressure 1 and injector control pressure 2. I got it set up for 1500 to 2800. So my buddy is going to get on it pretty good, and we're going to fill it when I'm going to yell when it does it. Go ahead. Injector pressure regulator's good, running pretty good. Right there, it's doing it. You felt it, heard it. It's going pretty good. Injector pressure regulator's good, pretty good. But look at the green one; it's all over the place. It's all over. It bumped right there. It jumped. It's all over on green. Green is injector control pressure number 2. It's going to slow down a little bit. Got a car ahead of us, but our injector pressure regulator looked fine. It never went way up, so that means I don't believe we have a leak in the system. And we're just watching our oil temperature get warmer and warmer. Did it right there. It's getting on it again. Right there. Right there. And it evens out. So the blue injector pressure regulator 1 seems fine. 2 seems it's all over the place, so we need to go look at that next. Well, just trying to go over this again. The blue's injector control pressure 1, the green is 2. Green is always all over the place. When it's sputtering and acting up, it jumps up. Kind of hard to see in this picture, on this little screenshot here, but it's jumping up. So what we think's happening is 2's jumping up. Sometimes 1 jumps up, but 2's jumping up because we think that injector is stuck a little bit, like stiction perhaps. Electronically it's good, but if it's got stiction, it's going to have cylinder contribution issues. And why does the pressure not go down but up? I think it goes up instead of down because the injector is sticking, and then it's reading that it's not opening, it's going to misfire, not misfire, but cylinder contribution on that cylinder or set of cylinders, and then all that pressure is going to go back on the transducer and read the pressure. So now we're going to have to get into schematics and look at some more. Alrighty, once in a while it'll show a camshaft position sensor circuit intermittent too, so might have to scope that as on focus as well. Alright, so what I think we want to do now, moving forward from all that scope, or not the scope, the scan tool work we did. Right there is your injector driver module. Behind that down there is your computer. This injector driver module feeds all these injectors, which goes into these valve cover gaskets on both sides. Here's your high pressure oil system on both sides, your pressure line going in, your HPOP, high pressure oil pump under there, feeding all that stuff. So, looking at the schematics here, what I think we need to do is a couple things. This right here is your fuel injectors and glow plugs for 2, 4, 6, and 8. And then from your injector driver module, same thing down here, 1, 3, 5, 7 from your injector driver module. We can scope anywhere on here, and what's cool about an oscilloscope is if it's stuck closed or stuck open or anything, you can see that on a scope usually because of the pintle movement of the injector, so we can scope that while we drive it. Also, what I want to look at is, here's your injector control pressure ICP sensor, which measures analog output indicating fuel pressure used for fuel control. We had pressure 1 and pressure 2. I only see one pressure sensor on this, even though the scan tool shows 1 and 2. We'll have to look at that. But it goes to the PCM, controls it. It's just a potentiometer basically. You got a camshaft position sensor, which uses information to calculate field delivery. We can scope that while we're running, because it had a fault for that. So I say we scope the cam, look at the fuel pressure injection control, as well as, like we said, the injectors, and see what we can find with the oscilloscope next. That's the way we're going to have to troubleshoot this Ford. Probably just use the MP408 oscilloscope, and we'll start doing that and go from there. Alright, so we're going to scope the camshaft position sensor next. It's pin 49 connector 1067 for the camshaft position sensor. I don't think that's going to be the issue. We'll scope it because these 7.3s don't have a crank sensor. They just have a camshaft sensor, and if you lose a camshaft sensor, it'll die. It won't start. It'll be a crank no start. So it's way down under there. But I got a lead going to battery negative. The other lead going to the back of the engine computer. Probe down there. Wires ran through the vehicle to my oscilloscope to get it set up. We'll do that next. Alrighty, now we got the oscilloscope hooked up under the hood to the camshaft position sensor circuit going to the engine computer. Take a look, there's our square wave. I got a trigger on there. One reason I'm doing this is because it said it had a cam sensor fault. I think that's just scan tool data error personally. This thing, if it had a cam sensor error, it wouldn't run, it would shut off. There's no crank sensor on the 7.3. It uses a cam sensor for field timing. If that was not reading, it would just die, wouldn't run. But you can see the changes there because of the reluctor wheel and encoder wheel. I get on it. A little bit of noise in the one area, but that's not causing our problems, I don't believe. I firmly believe we got an injector issue, or injector issues. I'm gonna get on it from a dead stop, but the cam sensor never drops out, so it's not a cam sensor issue. We got to scope the injectors next, I believe. It was acting up there, but nothing was causing us issues with the cam sensor not dropping out. 0 to 12 volt, 14 volt square wave with the engine running. So we'll go and scope the injectors next. Alright, so we're going to scope the camshaft position sensor next. It's pin 49 connector 1067 for the camshaft position sensor. I don't think that's going to be the issue. We'll scope it because These 7.3s don't have a crank sensor. They just have a camshaft sensor. And if you lose a camshaft sensor, it'll die. It won't start. It'll be a crank no start. So it's way down under there. But I got a lead going to battery negative. The other lead going to the back of the engine computer. Probe down there. Wires ran through the vehicle to my oscilloscope to get it set up. We'll do that next. All right, so now we're going to do injectors. These are the injectors, and those are the injectors. Heaters. I don't care about the heaters right now. So 1357, 1357, 2468. 1, 2, 3, 4, 5. 5 wires. So 5 wire, 5 wire. We're going to probe in B and D for cylinders 1 and 3, and B and D over here for cylinders 5 and 7 with the oscilloscope from the injector powered injector driver module. However, when we do this, battery ground, using the oscilloscope with an attenuator, because it can spike over 100 volts. The scope will blow at 100 volts. Now it can go up to 2000. Magnetic field collapses. It's probably going to go up to 150, 200 volts, depending on what it is. We're going to get that set up next. Alrighty. We're in B, which is a 10 wire, which is injector 3, which is down there. We're going to run it while we start it and scope it. Got my trigger on. And I got to move the connection around. Alright, I had a loose connection, but now I got it plugged in. Reading good. There's your direct injection diesel waveform. And you can zoom in on some of the stuff. It's obviously different than a gas one. Usually on a gas one, you'll see a pintle hump, like right in here, where it arcs up. That means it's opening. These diesel ones are a little different, obviously. Like, it's got all this injector. God. Hard to do this with one hand and film. You hear it kind of change in tone. It's some of the contribution issues. You can see that pintle hump right there a little bit. Right there. I'm going to check some other ones next. There's another cylinder, this cylinder. We did 1, now we're doing 3. Keep going to do the other ones. Little hump right there. Little hump right there. This is cylinder 5 here now. See the hump right? It was there. So I'm not going to do all these on video, but I am going to check them out, and then we're going to check out while we're driving down the road next. Alrighty, we're hooked up to an injector under the engine. We're going to take it for a drive. To really find which injector it is, obviously we'd have to scope all 8 injectors. I don't think we're going to do all that on here. I think honestly the guy needs to get that anti-stiction, the hot shot chemical, run it through there. If that does it, cool. If not, he's going to have to get new injectors. Alright, we're driving it now. Sorry, it's kind of rough. Again, we're in the roads of Mountain Home, Idaho. They don't really take care of them here. But, we're going to have to get up on the highway to get it to act up. Alright, we're getting on it now. Get on it, Steve. Felt it there, but it doesn't mean that this injector is bad. It's just, 7 other ones that could be getting sticky. It's kind of hard to tell on this scope. Get on it again. Pretty good there, though. Okay, slow way down. Alright, no cars behind us. I'll tell you when I get on it again. Okay, get on it. Make it happen. Right there did it. Yeah, I don't think it's this injector. We're going to have to switch to another injector next. Alright, so we did 1. Now we're going to do number 3. Hang on a sec, hang on. All right, you clear? If you're clear behind it, get on it. I felt it back there. It's running good there. Feels pretty good there. All right, we're slowing down. Get on it again. Right there. That feels pretty good. Right there, did it. All right, now we're on number 5. Go ahead and get on it. Running good there. Misfire there. Center contribution. Right there, pretty good. Nothing out of the ordinary though. We're going to switch to number 7 next. All right, we're on number 7. Go ahead and get on it if there's nobody coming. Feels good. Missed right there, did it. Good. Bad. Good. Pretty good. Doing it right there. All right, stop. Slow down. So if you look, we're good in those. Hang on a sec. All right, now that we pulled over, I can actually concentrate. So these were good here, but right here, there was no hump that I saw right here. Sorry about that, I just lost my phone. There was no hump that I saw. What is this thing doing? There was no hump that I saw right in here, and that's when it was acting up. Right there, I saw no hump. That's when I was acting up. Now cylinder 7, I'm not saying that's the only problem, but I think what needs to happen now is let me look at one other thing here. Yeah, a little hump there. I think what needs to happen, and I'm not going to do the other cylinders, it's going to be, we're going to find some anomalies in here. We need to get that Hot Shots anti-stiction stuff they put in these to clean all that, you know, stiction out, or get new injectors. I think that's what's happening. Like I said, I think these injectors, because when it was colder, it ran worse. As it got warmer, it seemed like it's running better. You know, and if it's something sticky like the injectors, their injectors electronically good, but if they're sticking, then it would be worse when it's cold. When it warms up, better if it kind of loosens up. So get that anti-stiction stuff, clean that out, and or get new injectors. And that's why I believe injectors stick and close. It's for whatever cylinder it's not firing in, or cylinder contribution, no explosion going on inside the cylinder. And if there's no fuel going, that's why your pressure jumps up. So that'll be the next step, is to talk to the customer and say, hey, get some anti-stiction stuff, run it, and go from there. If it still does it, if he wants to put the money in and put injectors in, I know injectors are for this are pretty spendy. So that is it for this 1997 Ford F-250 Super Duty, or Ford F-250 HD with this 7.3.